So what we're going to start working through problems or questions where we go through and what we say we travel through the networks. So we have different ways that what they call the way you go through the network. And often, so it sounds like, it's a map and we're going through parks and things like that. But that might not always be the case, but it does sound like that. But anyway, so let's go through. So there's names given to the way we travel through a network. So the first one here that we're going to look at is a walk. So a walk is when you go through a sequence of edges. So you're going to go through the edges, linking successive vertices. So that means you're going to go, one after the other. So you're going to go through. And so if, for example, so they've got a walk. So when you have to write out what you do, like how you went through the network, that's how you do it. So what we're saying is we're starting at vertex A and we walk down to C. So you might go like that. And then we went back to A. So it's a little bit hard to see that. So just say we went down there, we came back up here, and then we went down to D, and then down to G, okay? So then that's describing the way we did it. That's a walk. So a walk can have repeated vertices. So you can see I went into A twice, and it can also have repeated edges. And you can see I used the edge between C and A twice. So really what you can say, there's no restrictions with a walk. So technically, probably everything is generally a walk. And then when we start saying a few more restrictions, then they have another name, like a special name. All right, so the next one that we're going to look at is a trail. So a trail is a walk. So that's what I said. Nearly everything's going to be like a walk. But a trail has no repeated edges. So I'm never going to repeat an edge. So I'm never going to walk over one of those edges twice. So if you go start, and we've got an example here. So we went from B to E to F, up to C, back to B, and then A. So I'm just going to draw arrows in there. So we went this way, this way, this way, this way, and there. Now you can see we used the vertex B twice, but not the edge. So not an edge. So you can use, so you see we used the vertex twice, but not the edge, okay? So a trail is where you have no repeated edges, okay? So you can't go over the track again once you've gone over it. Okay, then the next one we're going to look at is a path. Now, a path has no repeated vertices. So you're never going to go to the same dot twice. So you can see if you have a look, we've got here a path. So I'm just going to draw it in the arrows. So I went from A to D to C, C to F, F to E, and E back to B. So you can see I didn't use a vertex twice. So you're actually probably in a path, because you're never going to use a vertex twice, you'll probably never use an edge as well twice. Okay? But anyway, no vertices used twice. So then we've got now we've got these last ones. Then what we talk about is a circuit. So a circuit is a closed trail. So like a circuit, if you have a circuit, obviously when you talk about electronics, you have a circuit breaker, it's because the connection's broken. So a circuit is you come back to the start. It's joined. So you can see it's a trail. So remember, a trail has no repeated edges. So a circuit is a trail that will come back to the same start and end at the same vertex. Okay, but will have no no repeated edges. So you might just want to write that. So it has no repeated edges. So the trail has a circuit is one that goes back. So if you have a look at their example, they went from A to C, C to F, F to G, G to D, D to C, over to B, and you can see I went back. So I did use a vertex twice, but I didn't use an edge twice. But what you want to know is if you've got a circuit, you start and finish at the same, yeah? So those letters would be the same if it's a circuit, and if it's and it would also have, because it's a circuit, no repeated edges. Mine's a little bit delayed there. Okay, so we've got the last one is a cycle, and it's a closed path. So remember, a path has no repeated vertices or the dots. So you'll see here we've got so no repeated edges and no repeated vertices. So when you have a path and you have no repeated vertices, you end up with no repeated edges as well. All right, so if we have a look at that example, so we went from F to E to B to C to F. So you can see you will start and finish at the same one. So if we have a look here, you can see you've got F and F. Now, because you have no repeated vertices, in between the start and the finish, you should always see different letters there. Yeah, you won't see the same different letters. If it's a cycle, you won't see the same because you never repeat a vertex. So that's a good way to know you've definitely got a cycle, because you won't see any repeated things. So I'll just draw the arrows in to make sure we can see it. So we went that way, like that, and then you're probably going to have this, this summary page open, and you start to get used to it, because it can get a little bit tricky when you're first learning. So the graph opposite shows how 7 vertices are connected. One walk is described as this. So off we go. If we drew out this walk, so because remember I said everything is generally a walk, because that covers everything. So we went A to D, we went over to C, we went down to F, we went over to E, and we went up to B. Okay, so if it goes, one walk is described, does this walk represent a trail or a path? So do I repeat any, I don't repeat any edges, so it could be a trail, but could it be a path as well? Do I use a vertex twice? No. So this one could actually be, could this represent, it could be a trail or a path, because we don't repeat, we have no repeated edges, but because we have no repeated edges or vertices, I would probably go with that this is a path, because we have a path. So, and just write no repeated edges or mainly vertices. So remember, a vertice is. Okay, so let's have a look. The graph below shows 7 vertices connected. One walk is, so if we go through, let's go through the walk here. So they're saying B to E, so we go this way. E to F, we go that way. F to C, then over to B. Now, so I've repeated B. So once you see that, you've got repeated vertices. So it can't be, we can't repeat a vertice. So what's that then? It's not a, it can't be a path. So we definitely have, it's always a walk generally, but this is a trail, because no repeated edges, but do repeat vertices. And it was vertice B that we repeated. Okay? All right. So identify then we got another one. Identify the walk here. So we started at F and we went to E. We went up to B. We went to C. And then we went back to F. So I went through, what would that one be? We have no repeated, yeah, I would say this one's a cycle. So we've started and ended and no more repeated vertices. So this one is a cycle because we've got no repeated edges. And no repeated edges. Edges or vertices, except for the first and last. Except for first and last. Okay? Okay, so let's do one more. It says the graph opposite has the 7 vertices and connected. Let's do this one. So you go A to C, C to F, F to G, G to D, D to C. So we've got a repeated vertex here already. So we've got, it would always be, at the moment, it would be a trail. And then we go out to B. But because we go back to A, so what's a trail that starts and finishes at the same thing is called a circuit. Good. So this one is a circuit. Because we repeated a vertice. And you can see in there, even though we started and finished, you can see the repeated vertice in there. So that would have to be a circuit. All right, so then we've got a little summary there for you. So a walk is pretty much anything, and it's like the basic one. So if you sort of break the restrictions on the other things, then it would just be a walk. If you have a walk that has no repeated edges, it's a trail. If you have a path, it's a walk with no repeated edges or vertices. If you have a circuit, that is a walk that starts and ends at the same vertex and has no repeated edges. So we can repeat the vertices in there. And a cycle has no repeated edges or things. All right.